Our today's lecture topic is exception handling. We'll see that what is exception and how we handle exception, and we will also see that why it is needed to do exception handling. To answer the first question, just think about it that whenever you have written a program, and it is very much possible that in your program you might face different error messages. The reason for having those messages can be that your some part of your code is not working, or your code is working but it cannot handle a certain type of data. To For instance, let's assume that I have asked you to write a program that takes a two number and divide them among themselves. Now you have taken, okay sir, it's very simple program, I will create a program with integer a b, then I will write division equals to a divided by b. So far simple. But what happens if someone gives b equals to 0? Now the compiler, okay, is not able to divide any number. Let's assume the first input the user gave was 7 and the second input, that is b, was 0. Now the compiler doesn't know the result of 7 by 0, because we know in maths 7 by 0 is an undefined, right? So in that case, what the compiler should do, because this is not a mathematical scenario, okay, you have to print this is a undefined result. So this is called one type of exception. Now to go back to the definition, the process of converting system error messages into user-friendly error messages is known as exception handling. So what we are doing, we are converting system error to user-friendly error message, okay, and this is called exception handling. Now this is one of the powerful C++ feature to handle runtime error and maintain normal flow of C++ application. Now what does it mean by normal flow? So let's focus this on here: handle runtime error and maintain normal flow of C++ application. Now think about this, okay, sometimes your program face different situation like this. Let's assume you have written a program that takes input id, student id, and suddenly what happens, some user decides to give a character, okay, because he didn't know that it has to be a student id. In that case your program will crash, okay, and it will get stuck. But the user, okay, he will see the program is not working, okay. So if you don't give a message that the why the program is not working or why the program is crashed, okay, in that case the user won't be able to understand what's wrong, because the user don't see the code, the user only see the execution file. So this is one reason we give user friendly error messages, that the reason the normal flow of the C++ application is not working because you have made this error. So this is the basic concept of exception handling. Now let me give you an example. Now let's assume this is a normal flow of the program. Whenever I run the program, what happens, if I take an integer, let's assume 5, okay, it prints 5. Every age has a language of its own, very normal. So this is a normal flow of a application. Now what happens, okay, by mistake the user doesn't know about integer, okay, whenever you use an application you are actually not concerned with the data type. So what happens, instead of giving integer, what the user gives a name, let's assume Sakib. Then what will happen, okay, you see it's printing garbage value 0. Every age has a its own language. Now if you have done the same in C programming, okay, in that case C wouldn't be able to handle it. But in this case it's printing a garbage value, but it is still printing. Okay, let's go for another example. Let's assume that I will divide a by as I said, to the division. So we will divide two numbers, that is a by b. Now let's take integer a, the division, and integer b. So sin b. Now let's, if we divide this two number, let's assume a is 5, then b is 2. So it's printing 5 divided by 2, that is 2. every edge has its own. Now the reason it's not printing 2.5 because we're not taking the float, we're only focusing on the integer. Now what if it's a 0 5 0? You see the program is not working. The program is not working. What doesn't matter, it automatically crashed, it didn't print. Okay, so this is called exception or error. Okay, so the program crashed without saying any giving you any output. Now to solve this problem, that means sometimes it can happen, right? So some part of your program will crash, okay, without, if you give a random input or if you press a random button. But whenever you use an application, when you use an uh, program, okay, sometimes it gives a notification. If you give a wrong type of data, it gives you that insert a name here. Okay, it also gives you like, this is the error, okay, try this way. So these, all these types, okay, these actually help you to use a software more easily, and these are called user friendly error messages. So to sum up the definition, to recapitulate, the exception handling is the process in where if the user by mistake gives some wrong input, or if there is an error by the compiler which the compiler can't calculate, for example, the uh, divide by 0, okay, it will give you a user friendly error message so that you can understand that, okay, so this is the problem, I can solve it in this way. And this is called exception handling. Whenever there's an exception or arises, it handles the exception. Now this is one of the powerful feature of C++ to handle the runtime error and maintain normal flow of C++ application. Now let's go to the next one. So in the exception handling, okay, there are different steps. The first step is that you have to find the problem, okay, that where the exception can occur. Then you have to inform about its occurrence, that is called throwing an exception. We will see the format in the upcoming slides, okay. But prior to that, let's focus on the steps. So we'll receive error information, okay, and finally we'll take proper action, that is we'll handle the exception. So first step in exception handling, to recapitulate, first one is hit the exception, that is we find the problem, then we throw the exception, and we catch the exception, and we handle the exception. Now you might say, sir, why this throw and catch? Are we playing games? It's that whenever we are writing code, we write exception handling normal program in one part and exception handling code in another part to make sure that it's understandable. So what happens whenever there's an error, the normal code throws the error to the other part of the code. So that's we call throw and catch. Okay, we'll go to that in the upcoming slides, so no worries. Now exceptions are runtime anomalies. Okay, so what is an anomaly? That you are giving a random input, okay, or there's a situation you faced that you didn't know. So that a program encounters during execution. The last program that I have shown you, see this one, it was a very normal program. Okay, there was no error from the programming part. Still, a random input by the user caused your program to crash. So this is the anomaly. Okay, a situation where the program has an unusual condition. Okay, because user not supposed to divide by 0, but still he did, and the section of the code containing it can't handle the problem. So we were in this section, okay, and as soon as we gave 0, it automatically crashed. It could not handle the part of this program. Exception includes conditions such as division by 0, the one that I have just shown, accessing an array outside its bound. For example, you have an array of size 10, but you decided to access array 11. Running out of memory, okay, your computer has a limited memory, and suddenly you create a variable that is could not find any memory. Now, so there are many examples, but you just need to understand the type of those. Okay, now if I go to the next slide, so why we use exception handling, I will come to that later. Now let's show you an example. So to summarize, to encapsulate, we have these 3 points, 3 keywords for handling the exception in C++ language. We have try, we have catch, and we have throw. So these are the three keywords that we use for handling the exception. Now let's see that what are these 3 part does. First, the try block consists of the code that may generate exception. So whenever you find that a part of your code, there's a possibility that it will generate an exception, or it might have an input that is not supported, you insert that try block. Now in the next slide, let me show you how it works. So this is the code. Okay, so try is with the statement that can have a exception. We use that inside the try block. Okay, then at the end of the try block, we write throw exception, and then we write another block of code where we write the catch block and the type of argument. So this is the basic structure of exception handling. We have try block, we have throw exception, and we have a catch block. So whenever there's an error in the try block, it catches the exception, it throws the exception to the catch block, and the catch block, it takes the exception and solves the problem. Now the question comes, what is a throw? So let's come back here. Throw keyword is used to when throw an exception encountered inside the try block. So whenever we face a problem that we take the problem, we throw it to the catch block. Or in simple terms, okay, what we do, we transfer the control of the program from one part to another part. Now, what does transfer and controlling means? So normally whenever you write a program, okay, the program follows a systematic structure. Okay, the program starts from this line. Okay, after this line, the program go to this line, and after that, the program go to this line. That means program keep compiling one line at a time. First line, second line, third line, fourth line, fifth line, right? Now, let's assume that even though we know it goes serially, one line at a time, okay, so it was going sequentially, and suddenly it faced a problem here. Okay, so what it will do, let's assume this is my catch block. Okay, I didn't write it, but let's assume I have the catch block here. So whenever it faces a problem here, instead of going to the next line, that is every age has a language of its own, it will take the program and it will send the program here, just like a function. Okay, so it will transfer the control from this part of the code to this part of the code. It will skip this line. So this is called throwing an exception, or transferring the control from one part to another part. Now, last part is catch block. Catch block catches the exception. Okay, that means takes the control, and then it tries to take actions that will define or that will solve the problem. Now let's go back here. So to summarize, to encapsulate, we have in exception handling is whenever we have an error that we couldn't know before. Whenever we're writing the program, it's not an error in your part, it's just a anomaly. What we do, we divide the code into two parts. Okay, from one part, that is try block, where there can be an exception, and then from there we catch the exception and throw it, and then there's another catch block in which we write the code that if you face this type of problem, this is the way you will solve it. So try block, catch block. Try block contains the code where there can be error. It detects the error and throws an exception, and catch block catches and handles the exception. So this is called exception handling. Okay, two part. Now it can happen in a simple code. There can be multiple type of exception as well. So in that case, what you will do? So let's start with the first example. Let's see how we can use one exception. So this is the program that I was showing you, that we have two integers, and suddenly if someone decides to divide it by 0, okay, what will happen? It will abnormally terminate, it will crash the program. So what we can do so that it doesn't happen, because the user might always try to give the program a different input. Okay, so we write the first line same as it is. You see, look at the first line, integer, number, answer. This line is same, number equals to 10. This line is also same, we don't have to change it, so we declared it in the first line, number 10. Then we take the second line, third line, that is this line, because this is the line where the problem will occur. There will be no problem in this two line, there will be no problem in this line, only this line will be the source of problem. Okay, just a minute. So this is the line where there can be a problem. So what we do, okay, we take this line, we write a try block, we write try, we two brackets, and inside that we write down the line, and then we write a catch block. Okay, and as this is an integer, okay, we write integer I, and then inside here we print denominator cannot be 0. So every time the user write 0, we will print the denominator cannot be 0, and then we will again go back here so the user can give the input again. So in short, we'll start from here. The user, as soon as the user gives 0, it will pass the code to this line. Okay, and then it will print denominator cannot be 0. Now the reason of having this structure, if we go back, that sometimes it can happen that from the single line we can have multiple type of error. Like for example, if I think about this, the try, okay, body of the try block. So here the first error can be you cannot divide by 0. So it's an integer error. So you will write a catch block integer I, and you will write the statement it cannot be 0. Then there can be another error that instead of writing 0 integer, the user wrote character. So you will, here you will write another catch block that the password or the number has to be integer. Okay, and so on. So there can be different types of error you can happen. For example, another instance is that, let's assume that you are writing a new password. Okay, so you know that whenever you're writing a password, there are some rules. Your password must contain 6 digit. So it can be one error that if you don't give a 6 digit, your password need to have a character. If you don't give a character, that can be another error. Your password needs to have one letter as well, and so on. So there are some programs where there can be different scenarios. Okay, so what we do, we write multiple catch exceptions. So this is the try block, and we write multiple catch exceptions. In this way you can actually make sure that in your program, doesn't matter where type of error there is, okay, you can always solve the problem. So this is the second example. We take two numbers, okay, and we divide the numbers. The problem is we know that whenever we're dividing the numbers, okay, there can be error. So what we do, okay, we write this line. So ignore this line, this is not needed. So what we do, okay, if both are not equal, okay, and if we see the number that we're dividing, okay, it is less than 0, okay, we throw an exception. Okay, and if there another type of error, okay, we throw another exception. So look at here, we have two exceptions, throw to throw. So what is the first throw is for? If n2 and n1 they are not equal, okay, n2 not equals to n1, okay, we throw n2. This is an exception. So this is out of this if else. Then if the second one is here, if we see the result is less than 0, we throw another exception. So from a single try block, you can throw multiple exceptions. Okay, now don't get confused that, sir, why if they're not equal, why we're throwing an exception? This is just for an example. Okay, you don't have to use it. Now you see the first one. Okay, the first one we have integer e. So what does it does? It shows that whenever whenever we throw e, okay, what happens? It comes to here. So it's exception division by 0. It can happen that you are uh, passing a character, okay, or you're passing a value that is less than 1. So it will be another exception. And finally, it might happen, okay, that you don't know about the exception. In that case, what we do, we use a catch block with 3 dots, okay, and then we write exception unknown, that we don't know which type of exception is this, but we know this is an error. It was not supposed to happen. Okay, so in this case, this is another example. You see, this is a program where with a equals to 2. So if the value of a equals to 1, we can throw one exception. If the value of a equals to 2, we can throw another exception. If the value of a equals to 3, we can another exception. So there are different types of exception we might throw, and then we have to write the corresponding catch block. So let me finish it here.